Good morning and good afternoon. Welcome to Snowflake Office Hours with WAG Labs, dog service provider, which includes sitting and on-demand dog walking. Frank Levener joins us from WAG Labs, where he is the engineering tech lead. His expertise is in database modeling, MySQL database architecture, security, performance tuning, and capacity planning in a multi-tier, high-volume production database ecosystem. Snowflake was engaged with WAG Labs as they were looking for a new data warehouse altogether. Frank was first drawn to the concept of near zero management. And my name is Jeannie Liu. I'm a product marketing manager here at Snowflake. I'll be the moderator for today's event. As you may already know, office hours are designed for attendees to hear directly from customers about their data warehousing journey, and more importantly, get your questions answered. Two quick housekeeping items. One is we will hold all questions until the very end, but please do type them in throughout the presentation. And second is the slide deck and recording will be made available. Frank, I know the audience is much more interested in hearing what you have to say, so without further ado, off to you.
Thank you, Jeannie, and thank you everyone for joining. Good afternoon and good morning or good evening, depending on where you are. So my name is Frank Levener, and I work for WAG. A little bit about me. I have about 20 years experience in database technology. I've been working with Microsoft SQL Server for about 12 years, then moved into MySQL. I have experience in database modeling and database optimization. WAG is a on-demand dog walking, sitting, and boarding. We are in about 43 states, 100 plus cities, and we do more than 1 million walks per year. So before Snowflake at WAG, we are using MySQL as the backend database, and as most startup company do, they use a reporting solution like Periscope or Looker. So they're using Periscope here at WAG, and basically we are doing a lot of query against the OLTP. Lots of join and business logic. The typical reaction, right, when you start facing issues on the OLTP side is to move the problem to another machine, to move those tables into a data warehouse, thinking that's going to solve the issue. So I'll go over this in a couple of slides, but that's where basically the issue we were facing here at WAG. We didn't have a data warehouse, and we had Periscope plug into a replica, MySQL replica, and we were building reports. We also had trouble unifying the data. We were trying to bring data from Facebook and Google for our attribution and retention, and that was pretty difficult. So OLTP system, right, are not meant for reporting. You can join tables, you can create table reports from them, but they are not meant for reporting, right? They are built for transaction, for fast inserts, selects on, primary keys, and that's the most of it. I mean, you can join table, of course, but, it's not built for it, right? So that's a challenge that a lot of companies face, because what they end up doing is they end up building reports on OLTP system that are not meant for reporting. And in order to get the data they need to put a lot of logic into it, right? They need to deal with all the business logic, and they need to translate that into query, which is very expensive in terms of number of lines that you have to write, right? You need to figure out how you're going to transform that data so that it makes sense, right? So you end up with a lot of queries, you end up with a lot of redundancy. And when you use tools like Periscope, you create a lot of dashboards. And because analysts have access to those dashboards, they create them, and usually you get lost, right? There's so many dashboards and nobody knows who is using them, how relevant they are, right? So it becomes really difficult to manage. So our situation at WAG was, as I mentioned earlier, quite complex. We were trying to, unify data from different data sources. Right? Today, just querying a OLTP system is not enough. You have social media data that you want to be able to, gather and join against your transaction table for example, our owners when they sign up, right, in order to build reports on attribution or acquisition, and that's difficult in a system that is not really built for that, right? So that's why we wanted to build a data warehouse at WAG where we can stream all that data into just one location, and use the power of Snowflake, right, to transform that data and build the reports for consumption. So the data warehouse goals at WAG was to use Snowflake as a data source hub, right, or also what's called a data lake. Because Snowflake's storage architecture is based on S3, right, you have basically limited storage capability. It's also inexpensive, and it really works like a storage. You just stream all your data, you create a database, and you stream all your data, raw data, right, into a database, and you can use that to transform. We also want to have all the data going into one location so that we don't have to wonder where is that data, where one place we know is in our raw schema and we can find it, and start using it. One of the most important aspects also is to control, right, the data transformation and the business logic translation. Something that is usually done, as I mentioned earlier, in Periscope, right? You put those business logic into your query. Here we transform the data, right? And we include in that transformation the business logic so that the tables are ready, for reporting. You don't need to add additional query and use if or use if no, et cetera, right? It's already built for you. So much faster reporting capabilities, or to be able to join different reports together. And also it's very efficient because those tables are built for reporting. There are few of them. You don't need to join and do left join, etc. It's really built for reporting and fast reporting. So a few words of caution, right? A data warehouse is not a place where you store everything and query everything like crazy. Of course, data warehouse can scale, and Snowflake scales very well, right? But you don't want to abuse it. You want to start small, right? You want to start with small warehouse unit and make sure you optimize along the way so that you can really grow exponentially. A data warehouse also is not an OLTP system, right? So when you move OLTP tables into a data warehouse and you start querying, what you're doing is basically querying an OLTP system. You're just using a different database engine. That's not really the purpose of it, right? You can do that, that's fine. But in the long term, right, you're going to face a wall. So a data warehouse is really meant for reporting. And in order to build those reports, you need to use a modeling technique adapted for reports. And for those modeling techniques, you use what's called facts and dimension. And they are very effective because they focus on the facts of the business, right? They really focus on what facts about your business that you really want to report on, right? So it makes you do some exercise, some thinking ahead so that you build the table properly. So a star schema, right, is very simple, fact table in the middle so that your eyes focus on it and this is your facts, and around it you have your dimension that will allow you to slice the data and group the data really differently. The way we use it at WAG is we build all those different facts. So we have a fact, for example, for a walk that has been requested. We have a fact for a walk that has been accepted by a service provider, which is a walker. And we have a fact for a walk that has been fulfilled, which is when the service completes. So as you can see, there's really 3 different facts that we track, and we have a fact table for each of them. And then we define the dimension in order to track those facts. So these type of schema are really optimized, right, for reporting. And they also focus on the business facts so that you don't need to think about it when you build your query. You know that that fact table is specifically for that specific fact. So by doing that, we were really able to streamline, right, our data ecosystem. We use Aluma in order to grab data source from different, to grab from different data sources, right? Facebook, Google, Zendesk, and it keeps growing. And also MySQL, we stream into Aluma, which gets stored into Snowflake into a raw schema. We then use a tool called dbt, which allows to transform the data. So this is our transformation piece, right? The loading and the storing gets stored into happens in Snowflake, but the transformation happens within dbt. And dbt then generates those facts and dimension table for you. It's all code-based. It follows a development cycle on you. It also gets committed to a repository. So all your business transformation, business logic, right, and then that transformation resides into just one location. So when a new data engineer comes on board, he pulls a repo and all the transformation is there. It's not lost in some complicated 200-line queries in Periscope into a dashboard that nobody has been using for 6 months. And we basically generate different data marts depending on the, for different departments. So now we are able to pull data, for example, from Google AdWords, right? And join with our owners to basically create attribution reports, which is very valuable for us. We also use Tableau, and we also use Periscope, where we publish. When we use our fact and dimension, we generate what we call flat table, where we grab all the attributes from different dimensions, join them with the fact, and generate just one flat table with all the records. We take advantage of like column architecture, which is very efficient, and we can, from that flattened table, we can generate any type of reports. And we also join different flat tables together. So after the implementation, we end up with very simple queries. Here we have a request, right, flattened table, which is all about services that have been requested, and a acceptance table. And this allows us to basically calculate ratios, the fulfillment rate, et cetera, et cetera. So why did I choose Snowflake? So I started working as a DBA, and there were no data warehouse. And I was asked to, if I was interested, and I took, the challenge. And I knew about Snowflake because I've been trying to introduce this new technology before in other company. And I really enjoy, I really like their technology, what they were working on, the fact that they were separating the storage unit from the compute unit, for me made sense. You have to think about the compute unit as SQL CPU, right? You can, using SQL, you can create what they call a warehouse unit of any size, right? And you can invoke those warehouse units within your SQL. So if you use a tool like dbt, which is all SQL based, you can invoke different size of compute power within your code to process and transform your data. So this is very powerful, and this happens on the fly, right? And then when you're done, you can shut them down or put them to sleep, or you can they go auto sleep automatically, because when you create them, you set the timeouts, and it can be up to, I believe, 10 seconds or even 5 seconds. So you can really save money by using this method. So cost saving, so true elasticity, S3 storage, so unlimited storage, right? Scalability, you don't need to worry about scaling your system. You can scale, you can build some very powerful warehouse unit and process a lot of data. It's really modern. There's technology like back in time where you can, using your SQL, you can actually look at data that is 30 days old, right? So you can go in the past and say, show me this data as of 30 days ago, right? Shared database where you can create a database, load data in it, and then share it to the public. Of course, those people need to have access to it, but that's also a very powerful, feature if you want to share within a bigger organization, right, data that you have in different departments, or also with additional other company who use Snowflake and can access your data. Zero maintenance. be cost saving, right? You don't need to worry about vacuuming or indexes or any maintenance, right? The only thing I do is it monitor the consumption of the credits, which you can set up alerts. There's a whole monitoring feature that allow you to track, who is using what, et cetera, et cetera. And also interoperability, which is third-party integration. It integrates very well with other vendors, right? Vendors are very smart. They saw the potential of Snowflake and what it can do, and they jump on board. And now they are rushing because they know that Snowflake has a lot of potential. So it's a great tool. So we've been using it for almost 10 months now. No issue at all. The learning curve is very quick, and the UI is very intuitive and very easy to learn. So some of my favorite features are resizing the warehouse unit via SQL, right? You can switch between those warehouse units by just using SQL. Easy access to documentation. The documentation is just one click away, so that's pretty. You can load data from S3 using a format. So you format the data that you're going to be importing and then use that into your copy command. I think is pretty handy. Zero maintenance, sharing the DB, and resource monitoring plus alerting. So some closing thoughts about Snowflake. I would say that by using all those different tools, Aluma, dbt, and Snowflake, we were able to build a data warehouse fairly quickly. We spent time on the modeling of our facts and dimension table. And today we are starting to really see, to bear the fruit of that effort, because everybody now wants to use the warehouse. They see what we've done. They've seen what we've built. And there's a lot of potential. We're able now to pour in it. There's room really for growth, and we're able to pour in it all those different data sources. We are not worried about scalability, maintenance, storage, and performance, right? That's something that, as a DBA, coming from a DBA background, right, I can sleep well at night. I don't need to worry about my warehouse if it's going to be able to perform. Also, being able to give the data engineer the power to scale their code, right, by putting those warehouse unit different size in their code is also very valuable. But they can monitor the performance and act accordingly. And also the fact that it can integrate with many vendors is very good. All right. I'm open for questions.
Okay, wonderful, Frank. That was very helpful. And we do have a lot of questions coming in. So I've done my best to bucket them accordingly. So I think the first thing we want to do is level set on the big misconception about data warehouse. So on slide 9, you mentioned that a data warehouse is not an OLTP system. Mm-hmm. What were you doing then before you implemented Snowflake?
We were basically connecting Periscope to a replica. I mean, we're still doing it because we're still in transition, but our goal is to get away from Periscope, caching table, right? Because it's not cheap. And querying MySQL, because you are, by doing that, you are querying an OLTP system. And our goal is to get away from that and query a, OLAP system, a data warehouse with, star schemas.
Got it, Frank. And as a follow-up, are all portions of your data warehouse infrastructure, so the staging, star schema, the OLAP, in the cloud, or is there a mixture of on-prem and cloud implementation?
Everything is in AWS. So dbt runs on the data engineer laptop, and when we push to QA, the QA environment, run the code and connects to Snowflake, and etc. The same thing for production. We use GitLab to schedule and run those, dbt code. And dbt is command line, so you just command and it will compile all those, those facts and dimensions for you, and also build reports, and also build documentation, which is something I forgot to mention. dbt has the capabilities to build your entire data warehouse, all the facts and dimension and code documentation for you, and then you can export that into AS3 bucket and serve that on the web server to expose the entire company. So a very clean and efficient way of building your data warehouse.
Excellent. And within Snowflake, are you using dimensional modeling star schema, or are you flattening the tables and reporting based on the flattened tables?
We first build a fact and dim. That's the first layer. And then we build our flattened table from the fact and dimension. From the flattened, because we use different facts, right? So we have the acceptance, we have the request, we have the fulfillment. Each of these are going to be a flat table, but they all have, a key that is common, and we can join on the fact and build some additional reports from there. And we can also link to, for example, Google flat table, Facebook flat table, right? And generate some pretty sophisticated reports.
Perfect. This is a two-part question. So, Frank, you use Illuma to grab data from different sources. So does this data live outside of Snowflake, or is it part of the Snowflake Cloud Services layer?
It is part of Snowflake. I created a schema called DW raw, and a database, in Snowflake. And within that database, I created different schemas. One for LTP, one for SaaS, one for marketing, etc. And depending on where the data is supposed to go, it will go into that schema. I basically followed Illuma categorization of the different data input, which I thought was useful, and I mimicked that. And depending on when I create an input in Illuma, if it's going to a marketing, then it will flow into the raw schema in marketing, so that data engineers know now, they understand where to get the data and where to join.
Great. And then as a follow-up, so you mentioned that the loading and data happens in Snowflake and the transformation happens in dbt. Mm-hmm. So using dbt, does transformation flow back to Snowflake?
Correct. Yes. The dbt tool, it's all select statement, right? There's no insert, update, delete. All you do is you write select statement to basically grab the data from the raw. And you create, table, and you join them, and it generates the fact and dimension table for you. dbt also is a smart tool. It knows about dependencies, so he understands that dimension needs to be built before the facts. And if you are also building reports, it knows that the fact and dimension needs to be built before.
Great. So let's shift gears from the actual ingestion and transformation to the product itself. So what are you using to monitor and alert?
Well, first of all, there's no alerts. I mean, actually, there was one a couple of months ago, last year, and Snowflake notified us by email. But in terms of database itself, there's nothing to monitor because it's not really on our side. If there's an issue on Snowflake, we'll get just alerted by emails. The only thing we monitor is the resource consumption, the credits. And on that, you can set up alerts per warehouse unit if they reach a certain level by day, or by month, the consumption, and you get notified. So what I did is I put basically a 50% consumption per month. If it reaches above that level, I get notified, and I start taking a look, seeing why we're consuming more credits than we should.
Great. Thank you, Frank. Super helpful. And then now let's move over to the selection process. So did you evaluate any other cloud warehouse, such as Redshift, and what did you see as the key differences between the two?
Well, I personally didn't use Redshift, but I was exposed to it at my previous job, and I know what the DBA went through, the pain. So based on that, right, I knew I was not going to go use the same tool that we're using, because first of all, you need a DBA, and you need to maintain it, right? So I wanted our team, our data engineering team, to be very lean and focus on what we need to do, which is build, fact and dimension for reporting, then maintain it, our data warehouse. And because Snowflake is basically auto maintenance, you don't need to do anything. Then, for me, it was a no-brainer.
Great. And then also related to the selection process, can you discuss your decision to use Illuma versus your own ETL tool? What was some of the deciding factors?
There was a couple I looked at. There was Fivetrend, Stitch Data, which just got bought by Talent, and a few out there. What I liked about Illuma is the tool has different components. One is a code engine, which is Python-based, which allow you to transform events as they come through. Their underlying architecture uses Kafka, which is scalable. They have a caching mechanism, so if any events are unable to load into Snowflake, it will get cached, and you can fix the error and then re-inject those events into the warehouse. And it works very well with Snowflake. It generates the table for you. It identifies the source. So, for example, for when we connect to OLTP, it will understand the table and generate the table for you in Snowflake using the proper data type, which is very time-saving. And when we do modification on the schema, right, it modifies it into Snowflake also. So really low maintenance again there. Illuma does the work for you, and the event just keeps streaming and loading into the warehouse. You have also flexibility to schedule how frequently you want the data to load. They also done some optimization using Snowpipe, which is a way to load data into their warehouse much quicker. So it's a good tool. It's a very good tool.
Great. Now let's shift gears to the implementation. So say that I'm a one-person data team. How much time does it actually take up to set up Snowflake?
Well, really no time. The time I spent most, honestly, was to figure out, okay, what database I'm going to create and what schema I'm going to be creating, right? To figure out how I'm going to arrange my different databases and schemas. And so once I've done that, then after that, it's just a matter of using it. Of course, also granting the proper permission. So there's some learning there. But if you have experience with database, the grants are very similar. They use roles. So I created roles for the data engineer, a role for Periscope, a role for Tableau, etc. And then after that, you keep adding users to the role, and they inherit the permission. So that's really where I spent most of the time, to set up the data warehouse. There's no. I started with the smallest warehouse unit, and there's no really tuning like in MySQL. You just create things and you grant things, and then after you start using it.
Excellent. Thanks, Frank. So for everyone on the line, we are at the half-hour mark, but we do have a lot of questions coming in. So I will continue. If you do have to drop off, thank you for joining, and we'll see you at the next office hours. So this is an interesting question, Frank. How do you enforce bad queries so as not to increase computational costs?
That's good questions. So Snowflake has a history feature, which allow you to look at all the queries that have executed. You can filter those queries by warehouse unit, by user, or by also SQL text. And it tells you exactly how the query was executed, where the time was spent, right? And you can optimize them this way. We haven't really focused on that yet because we haven't experienced any issues so far. I would say DBT is pretty good at generating efficient queries. But I know that's something that will come down the road where we grow and the data grows, and we'll be focusing on maybe optimization. But you can do that. You can monitor those performance.
Great. And did you establish any referential integrity in Snowflake, or is it out of box?
Snowflake doesn't support primary keys or foreign keys. This is enforced by DBT. When you build your fact engine within DBT with the code, you can create what's called tests, right? And those tests can verify that to make sure that there's no orphans, right? That you have foreign keys for each record into your fact. You can do some counts, to make sure you have uniqueness, et cetera. So there's a lot of things you can put in dbt, and those tests will run. And if it fails, then you can notify, and then you can go back and try to figure out why, fix it, and then rerun it again. So all this is done on the on the dev side. All the data engineers have their own platform, and when they run their code, they see those errors, they fix it, and then that gets pushed to QA, etc. So it's really what I love about dbt. It really follows the regular development cycle, so that when it gets pushed to production, there's quality there, right? It's been tested.
Excellent. This also has to do with your environment. So can you give us a sense of how large your Snowflake implementation is? Are we talking gigabytes, terabytes, and number of tables, number of users? What's the magnitude of your implementation?
Well, we are in the terabytes right now, because each data engineer have their own basically database in Snowflake. Creating them is very fast. You can also clone, right, database very quickly. So we wanted to give independency for each engineer so that they don't interfere with each other. But in terms of if I would take one database by itself, the raw schema, the raw database, it's probably the biggest because this is where all the data comes through. I'm not sure how big it is, but right now we are in maybe 20 terabytes or 16 terabytes of data usage. We have maybe, I don't know, it's hard to say how many tables. I think it doesn't really matter for Snowflake because it can scale, so well. In terms of users, maybe now we are 30 users, 5 data engineers, and then analysts, and Tableau, and really what I really like is now people know. They know about the data warehouse, they know about Snowflake, they know what it can do. So now everybody wants to get access. So every day I keep adding people, to Snowflake.
That's great to hear. So it sounds like Snowflake is adding value to WAG Labs. Mm-hmm. A couple of follow-up questions. So how do you manage job scheduling and job creation in Snowflake?
Everything is done with dbt. There's a few things that, for example, because we use also other database, we need to sync some data. We use bash script, we export to S3, and we use the copy command in Snowflake to load that data into the warehouse. But very few of them. The rest, anything related to data transformation, is done in dbt. Anything related to data sync that is not done via Luma, that's done via bash script.
Great. And you had mentioned Google Analytics earlier. Above and beyond that, what analytics tools are you using for data delivery and also visualization?
So what we started doing, because we want data, because the data analyst, right? Periscope is a broad, basically, or I would say, set up a data culture, right, around querying the OLTP. So you cannot move people using Periscope to Tableau, like this. It's a change, and it needs processes. So we started using Tableau. We're using it for a few departments. We're still using Periscope. So what we started doing is those flattened table, right? We started sharing them. Sharing them in Periscope. So the data analyst, right, can still query the Snowflake flattened table and build reports. So by doing this, they become familiar with the data warehouse. They become familiar with the flattened table. They start to understand, okay, flattened table are built from fact and dimension, and slowly they're moving away from the OLTP world, right, and start using the data warehouse.
Excellent. And does WAG Labs use ODBC or JDBC connectivity with third-party tools currently?
I believe it's JDBC, yes. But Snowflake provides ODBC, JDBC has Python. It has a lot of ways to connect. You can also connect Databricks, Spark. The connectivity is pretty, sophisticated, so no issue there.
Excellent. And more about your environment. So how frequently is data ingested into Snowflake? Is it nightly, hourly? Do you have any real-time or near real-time data needs?
Data is injected daily because, that's for the warehouse, that's where you want to be. Real-time in the warehouse, I don't know. For us, we don't have yet real-time. Near real-time needs, maybe. But for now, we're focusing on our daily reporting in Snowflake.
Great. And I know you answered a question similar to this, but what size Snowflake instances or clusters do you currently work with?
We use the smallest. We have one, I think, for the loading, because that's where the consumption, with all the inputs we've been adding through Aluma, I had to basically, and you can, the thing about Snowflake, you can scale different ways. You can scale up by using a warehouse unit, which has more CPUs, but you can also scale horizontally by using what's called cluster. And what I like also about Snowflake is you can scale automatically. So I created a warehouse unit with a cluster between 1 and 4. And Snowflake will decide when to use 4 or when to use 1 or when to use 2. So, and I monitored it and I saw it using the historical feature that some queries will use 1 cluster and some will need to use 2. The size is the same, but basically you're adding concurrency, which allow you to process more query.
Excellent. A couple more questions for you, Frank. So,
sure.
What is the benefit of using dbt for building facts and dimensions versus using views within Snowflake only?
Well, if you were using views, you would be, querying raw data. dbt transforms the data for you, so it requires some understanding of the business facts, and you need to build the query accordingly. So sometimes in dbt you have to join maybe 5 or 6 tables, right, in order to produce that final table that's going to be used as a dimension or your fact. But at least your logic is in dbt, right, and it's in the Git repository, so everybody can access it, has view on it. And then you can deploy it very easily, right? You hire somebody new, it pulls a repo, it runs the code, it will generate the fact and dimension immediately, right? And you'll have the same, basically, fact and dimension that are on production. So that's really what I like about the dbt is centralizing all this business logic and data transformation into one place.
Great, and let's wrap it up with this last question here. So for the audience on the line, what were some of the lessons learned in your implementation? So can you talk about some of the roadblocks or hazards that you faced, and how did you overcome them?
I would say the major one was the Tableau adoption is not easy. Especially when you have a data culture that is using those tools like Periscope, data visualization tool like LookML and Periscope that are plugged usually against the OLTP system. So that's a challenge because the consumer of your data warehouse are most, generally going to be your data analysts, data scientists. And, they're used to querying the OLTP, they understand all the table, how to join them, and having them to shift and start using the warehouse is not a simple step. It takes time. And, Tableau is also another way of looking at data. Doesn't work the same way as Periscope. So it's another change. So these take time. You need sponsorship, right? You need sponsorship at the high level, and someone has to push forward. Right? This is where we're going. These are the reason why, right? And everybody has to follow, because otherwise, if everybody wants to, if you have resistance, you're not going to go very far. So sponsorship at the high level, who understand what the company is trying to achieve, at the data warehouse level, I would say is critical.
Okay, well, thank you, Frank, and thanks for everybody on the line for joining. Frank, we're excited to see how Snowflake adds to WAG's mission of giving pet parents more flexibility to basically manage everyday life and giving them access to experienced and trustworthy dog walkers. So excited for your success, and we'll be rooting for you from the sidelines. Everybody on the line, if you have other questions, please do follow up. We will follow up with a slide deck and recording. Otherwise, have a great day, and we'll see you at the next office hours. Bye-bye.
Bye-bye. Thank you, everyone.